Hi everyone, I'm glad to be here to talk in front of you all. So, most of the team out here must have been fed with the same belief that the three things cannot coexist. What I'm referring to is a system being capable, compliant, and as well as offline resilient. Here in this forthcoming talk, we are going to walk through that this is a false belief and all these things, three things, are not in conflict but can be made to exist together by taking a same architectural decision that two made at once. Hi all, this is Akhil Gupta and I'm going to present you a one AI clinical assistant prototype. It's a prototype called EdgeMind that showcases by using the frontier class model and the MCP plane, we can do the evaluation for the whole system completely offline with no cloud call, no server, and no data leaving the device at all. So the topic we titled as the policy, the protocol will be sending 0 byte to the cloud and zero LLM tokens. Now, if you look at the slide, the very left side, we can see that compliance is no more a luxury for for the industry. It is an obligation. India's DPTP Act is already in force. It's no longer pending. The GDPR compliant protocol is something already in the market and it's more than a decade now and it already has enforcement teeth. Moreover, in case we are from the medical or the banking domain, we have the sector mandate stacked on top of that. So the point is that compliance is no more only about to keep a data safe, but it about to how to ensure that the data doesn't leave the jurisdiction and also it's auditable and we can answer the history for the autonomous decision taken at any point of time. What we can say that it's a data requirement flow. It's no more a policy oriented. If you see the right side, this is how our default AI system looks like today. User writes a prompt, the prompt gets serialized and it's being handed over to Cloud API. Thereafter, we don't have a clue where the data actually went, and we expect our auditor not to come up with the question. That is something not feasible practically. Moreover, this comes with the three costs. The costs that comes are like primarily the token charge per query, that's something quantifiable. Then we have round trip latency for the cloud, that's measurable. And above all, if the network that we are relying on is not trusted, then whole production deployment is at stake. Now consider the scenario where this becomes very critical. Think of a nurse doing an operation in the basement or an engineer in oil refinery with no signal or a defined system which cannot wait for the TCP handshake. They don't have a luxury to send the data over to the cloud. Moreover, in that case, sending data over to the network is not at all just a technical glitch, but it's more like a compliance breach. So, what's the solution? Solution is what if I say the compliance sensor and the reliance sensor are the same? What makes it feasible? Yes, that's MCP. So, if you look at the thesis, what we are talking about that the power of MCP at the edge is not only a tool calling, but can be visualized as a protocol that acts as a single choke point that decides which AI model to be called, what are the privileges user has for which tool he can call, and also the auditing or the governance rules. Everything should be defined in a local pass, that too before data leave the device. If you look at the architecture to the left side, the pipeline starts with a view model, which is a set of 5 Kotlin file. The data gets compressed and goes to the MCP client, where based on the scoped capability token, the data goes further to the MCP server, and MC server consumes the data, but not over the network or the socket, but it's completely a coroutine dispatch. or you can say a server is a class here in the same process. We are not sending data over the network. So as a bottom line, what we did is we kept the protocol, but we deleted the network. What does that mean? It means starting from the security gate to guard model to IAM service, triaging, or the inference, everything is being done as a part of single pipeline, that too on device, even before a data touches the air. This brings us the two capabilities. The very first one, we are able to quantize the model to info quantization that can fit into the mobile or any memory constrained device quite easily. So we need not to use any API key and there will be no cloud bill. Secondly, since there's no provision for data egress, means the GDPR or the DPDP is by default is a structural guarantee. So it's not at all a policy document. It's more like an architectural property that we ensure that during our architectural design only that no data leaving the device. Hence, there's no way that data going out and we are compliant with the GDPR or compliance. But the point is, how does these three things, the security and the governance as well as the auditing, is possible in a one go? That we'll walk through by showing how the control plane works. But before that, I need to spend some time to understand, to make you understand why the heavy lifting is being done by the executor. So executorch is basically a project from PyTorch, and it's a lightweight runtime inference engine that makes us the model to run for inference AI model on the memory constrained devices, and it comes with a yeah yeah, and it comes with the four capabilities. Primarily, the torch.export method is something that makes the execute torch feasible to evaluate the computational graph directly from the model. There's going to be no format conversion, no different separate runtime. Be it a 5.3 model or Whisper model, everything will be get created, composed into .pt artifact, and that .pt artifact is something that would be run on the inference engine. So we don't need any separate inference engine as such. Secondly, int for quantization and the static memory compilation that makes a 5.3 model to get composed from 14 GB to as good as to 2 GB of space that can easily fit into the mobile or the Android phone. Secondly, the static memory compilation makes it ensure that at the inference time it doesn't get latency or the pauses because of the garbage collection cycle running in. So we need not to we need not to do a trade-off with the garbage collection running when inference is there. So we can address that latency. Thirdly, the Qualcomm STP delegation. The QNN partitioner is a feature from Executorch that codes the quantize operation directly to STP, that's hexagon tensor processor, Qualcomm fixed NPU. Now, obviously, NPU is something that's faster than the CPU, and we have a fallback mechanism as well. And fourthly, and very important, like the executors come with the training API that's rank at LoRa that basically makes it happen to train the model on the device itself. So for the training and the inference, the same runtime engine is being used. I have to go to office in some time. So since the training and for inference, the same runtime is used and no data is leaving the device, means the model improves over the period of time as well as there is no privacy liability. Just to reiterate, there's no other framework, be it on X runtime or TF Lite, that gives you all the four features together. be it a quantization to info, a native support to PyTorch model, or with integration with the Qualcomm STP, or eventually for the training using the federated training model. Now we'll see in the next slides how this is possible. So the control plane basically addresses the security, the governance and auditing all in one go. The security brings in the guard model and the sign capability tokens that block the unauthorized access, prompt injection, or content misuse. Governance that decide based on the confidence level which LLM to should serve the query, and auditing that something comes with a provable mechanism to store any act of done by the autonomous tool by using SHA-26 hashing. So going on to next, we'll see how the security and governance are basically addressed. For the security perspective in the pipeline, we have two gates defined. Gate one, something addresses a query about whether the query is legitimate. That's a check at the prompt level. And for any query, even it's legitimate or no, the SHA-26 hashing is used so that we need not to store the raw content and we have the auditability maintained. Subsequently, there's a gate 2. Even if gate 1 passes, gate 2 checks for a completely different question. It looks for whether the query, despite being attempted, is it something within the scope to be called to call a particular tool. So this blocks if the user is legitimate but he's underscoped. The first one blocks any malicious prompt. So we are able to block both sort of queries. The scope for the agent is defined at the runtime with the default one for wherein a agent have an access for the SLM inference as well as knowledge base. Then we have elevated where LLM would be called, have LLM access, and then we have system that have an access for sensor and audit right. The key backing the JWT never leaves the Android key store, so it cannot be forged. Now, if you look at the right column, we can see the 0.75 router. It's something a baseline that define how the queries will be addressed after both the subsequent gate 1 and gate 2 has been through. So we see SLM would be fired for every single query, and mostly 80% of queries are anticipated to be addressed by SLM. Subsequently, if the confidence score by the logic distribution is something below the threshold of zero point 0.7, it gets the data again enriched with the RAG along with the SLM, and subsequently, if still the threshold is breached, it will go for LLM. That's the context model, and will handle the issue. So what we say, nothing leaves the system. Data is within the device. So why? Because it is compliant by the construction. There is nothing to leave. So by structure itself, we are able to address the issue of GDPR and its compliance itself. Not even for federated training, there is no egress. And every action is possible because we have a scope token and we are using hashing for maintaining the logging as well. Now, moving on to what makes it generalize. We can think of this system as a platform but not as a product. That is something for illustration we can say is applicable to 6 different verticals. Be it logistic, pharma, oil, gas, emergency services, translator, or sales or customer experience. Everything is domain agnostic. Even this application or the product, it doesn't know anything about the clinical triage. So the baseline is, if we want to ship it for different vertical, we just need to swap the three file. That's corpus domain and the model PT. Corpus JSON is something like a knowledge base for the domain. Domain face is the index created on top of it, and model PT is the subsequent corresponding model composed in a PT format. So think of it like in the logistic scenario, the same application can be used for triaging and for field operations to run the route and inventory queries offline. For formal medical, drug instruction lookups can be done by the user in a remote or low signal area. And if we think solely about the Salesforce with the customer experience, it's able to replace a bill of 450K dollars per year annually with 500 representatives. This is the proven stats on their website. And this is what we are talking about even before we have taken into account the compliance auditing costs savings. Similarly, for logistic, 109,000 of dollars of cloud token spend can be bring down to zero in one go. So if you are an engineering lead thinking to implement it, you just need to get the boundary, that's MCP orchestration, the security check, the inference, the runtime, the federated train, everything remains safe. You just need to bring the domain and the system bring you the governance. So here's my queue. So now one more thing that we just forgot to talk about. What's working today and what's on the path. So in this process, the capability scope JWT token tool registry is working. We have two security gates, on-device guard model, Android keystore backed IAM running before the call. Everything's working. Fine vector search with Kotlin cosine search is working. LoRa is also working. What we need to go through is like the re-verification for the JWT token is not yet being done. Even the gamma integration is on the way. So these are the known gaps, but not the risk. Every one of them has a clear engineering path. The architecture you have seen works now. The roadmap item makes it production hardened. So quickly we'll go through the demo.